Hello everyone, I am Chandan Kumar and I will talk about our work focusing on a multimodal approach of eye typing. We all know eye typing is very useful, especially for people with motor impairment who cannot control mouse and keyboard precisely for text input. And that's why in past decade, actually past 2-3 decades, there have been plenty of eye typing approaches being proposed. However, the acceptability and usability of these approaches face several problems related to performance, learning, and fatigue. Here I have included a table consisting of the most prominent approaches from last 10 years. As you can see that performance is rather low, especially in the first session. Also, a considerable practice time is required to achieve a speed of 10 or more words per minute. If we categorize these approaches in terms of the methodology, there is the most common method of dwell time. If the dwell time duration is too high, of course the typing speed is low. If the dwell time duration is very low, people make a lot of mistake. In general, all the users need time and learning to get adjusted to the dwell time period. There are also dwell-free methods like Dasher and iWrite, which uses completely novel and customized interface where user also need a lot of training to get used to these methods. There are also dwell-free methods like iSwipe and context switching where user needs specific gesture like look up, down or left, right to be able to do a particular selection, which also requires learning and also tiring for the users. In general, all the gaze-based typing methods of course tiring for the users because eyes are a perceptual organ which are normally meant for looking and observing, not for selection. To overcome some of these limitations, we propose text swipe, where user just glances from the first to the last letter of a word, while an additional modality of touch, press, and release can be used to signal the start and end of a word. It's very similar to the swipe method that we have been using in our phones, where touch interaction can be used to signal the start and end of a word. However, in this case, we use gaze gesture for the swipe rather than the touch interaction. In this way, of course, it's less tiring for the users because eyes are used for their normal behavior of just looking through the desired word. We also do not require any customized or novel interface to enable typing. Furthermore, since it's a word level input method, it requires less effort compared to the character by character input. We also include some of the additional gestures to enhance the typing experience, which we will demonstrate in the next slides. In terms of the applicability of our approach, there are many people with motor impairment who do not have complete control over hand and finger movement. However, they are still able to do a coarse interaction like a tap. Also, many old people do not have precise mouse and keyboard control, can use text swipe method. Also, if the interaction is fast enough, many of us will be able to use text swipe in specific scenarios like holding a tablet, thumb can be used for touch and gaze can be used for swipe. Let me explain you the basic concept of how you can type with text swipe. Let's say you want to enter the word gaze. Of course, your visual attention starts with the first letter G. To confirm that this is the first letter of the desired word, you do explicit confirmation by touch press. You just look through the intermediate letter of the words, and when you are at the last letter, either you simply remove the touch, I mean lift the finger, and then the most relevant word will be automatically entered. While lifting your hand, you can also do left or right swipe to select the alternate candidate of left and right suggestion. You can also do a down swipe to delete the word. As per the implementation, as you can see, smartphone was used as touch input which can be connected using a QR code. The keyboard itself was developed as a web application using JavaScript. For the execution of computational algorithm like word path computation, Django framework was used. Since it was a web application, we used i-based browser developed by us previously to run the application. An important part of the word level text entry approach is how to generate the top candidates. Here I try to provide a very simple explanation of the overall approach. Since we know the first and last letter for sure from the user input, we try to filter and find a subset of words which start with a particular first and last letter. So let's say from the previous example when the user wanted to enter the word gaze and the first letter is G and the last letter is E, we have all the possible set of words like give, game, gaze, guidance, guide, etc. All these words have an ideal path in the keyboard space and then we have the gaze path recorded from the user interaction. Both these paths are like a time sequence data and we do a sequence analysis to compute the similarity between gaze path and all the possible word paths. We use dynamic time wrapping algorithm also used in different swipe methodologies before. Based on the similarity, we rank the candidate and show on top of the key for the user interaction. Here is the actual demo of showing how user type with the text swipe. We evaluated our approach with two other methods, dwell time as a baseline and iSwipe, which is another word level input method closest to our approach. In the next slide, we will show our implementation of dwell time and iSwipe used in the experiment. Here you can see user entering each character by dwelling on it. Here you see the implementation iSwipe where you see a pop-up button which is also called action button where user need to look up and down to do a selection. The experiment was a 3x5 within subject design. We had total 12 participants. Each participant tried all three input methods. For each input method, there were 5 sessions. Each session included 5 phrases to be entered. We used the SMI eye tracker. Dwell time method had 600 milliseconds. Of course, counterbalancing was used to nullify the effect of training. In addition, we tested only one method a day, and that's why participants had to visit the lab in 3 different days. In terms of text entry rate, as you can see, TextSwipe outperformed other two methods significantly over all sessions. Some interesting thing to notice that each user can at least achieve 15 words per minute using TextSwipe, showing the potential of TextSwipe with each user. However, some of the users could only type 7 words per minute using iSwipe and Dwell. The maximum text entry rate for TextSwipe for a session was 20 words per minute. Some of the users could even achieve 29 or 30 words per minute for a phrase or a sentence. The error rate was also considerably low compared to iSwipe and Dwell. We also performed some statistical analysis to understand the difference between the two word level input methods. For example, the correction rate with iSwipe were higher, so more often the words were deleted. This could be due to the incorrect first or last character, or simply the desired was not found in the candidate list. The very important aspect is actually the accuracy of the first and last letter for an swipe based method. For example, in our experiment, if the first and last letter was entered correctly, 98% of the times user can find the desired word in the top 3 candidates. Also, in that respect, TextSwipe had a higher accuracy rate, which shows combining touch with gaze for doing a selection of first and last letter is more comfortable for user compared to doing a specific gesture. Also, for the subjective feedback, TextSwipe was rated much higher on the scales of speed, accuracy, comfort, and learnability. Participants especially found TextSwipe much more relaxing as they could control what is happening on the screen compared to the other two methods. Especially for iSwipe, it was a lot of learning required for the users to get used to the reverse crossing method. Especially when the pop-up button overlaps the other characters, the interaction becomes even more difficult. In terms of overall preference, 10 of the participants actually chose TextSwipe and 2 participants chose iSwipe. Additionally, we did a small study to understand if the multimodal aspect of touch plus gaze would be used for a character level input instead of the swipe based methodology of TextSwipe. And we found that TextSwipe, of course, was 30% faster than touch plus gaze. It is quite obvious because hand-eye coordination for touch plus gaze method will be required for each character. In conclusion, we propose TextSwipe as a novel method that combines simplicity and accuracy of touch with the speed of natural eye movements with an state-of-the-art performance. An interesting thing to note is that TextSwipe could achieve 14 words per minute in the first session itself. However, most of the other approaches report 5 to 10 words per minute in the initial sessions. Although participants found it much more comfortable and also liked the playful experience of touch, swipe, and lift. Also, I would like to mention that although we use the mobile device and hand-based touch input for experiments, the applicability of TextSwipe concept is also valid for other means of interaction. For example, one of the participants was really curious how the TextSwipe system would perform with the feet interaction, so he used the same mobile device as a feet pedal and could achieve 15 words per minute over 4 sessions. Not only feet interaction, but there are a wide variety of switch input devices which can be easily integrated in the TextSwipe concept. Also, there are touch and gaze enabled devices like Tobii Dynavox, where the TextSwipe concept can be directly reached to the end users. Also, such a multimodal concept could be easily integrated for interaction in virtual reality environment. Thank you so much for listening our talk. For more details, follow our paper or please write us an email. Thank you so much.